Hello class 7. In today's class, we will discuss about heat and what effects heat can bring. Okay? Heat and its effects. First effect that heat brings is change in temperature. You give heat, temperature of an object rises. You take away heat, taking away heat means what? You cool it. So when you take away heat, temperature drops, comes down. So this is the change in temperature. As simple as that. You add heat, temperature increases. You subtract heat or you cool it, temperature decreases. Second effect that heat brings is change in dimensions. Now what is the meaning of the word dimensions? Dimensions means length, breadth and height. Together they are known as dimension. So when you heat, if it is a thin object, that object will become longer when you heat it. Okay, when you heat, it increases in its length. Or if it has a broad breadth as well as the length, then length and breadth both will increase and you will have change in length and breadth. Length and breadth together means area when you heat. When you heat again, if there is length and breadth as well as height, then all the three, length, breadth and height, all will increase, and together we say that the volume of that particular object increases. Okay, volume is length into breadth into height, remember? So heat brings about change in dimensions. Shape, you can say. Shape increases due to heat, and when you cool it, then the shape decreases, comes to its original form. Third one is change in state. Now this we have studied in lower classes also. When you heat an object, when the object reaches its melting point, then it changes from its solid state to liquid state. Again you heat it and heat it till the object reaches its boiling point. Then from liquid state it changes to gas. This is when you add heat. Now opposite will happen when you subtract heat. You minus heat, that means you cool it. So when you cool gas, when gas is cooled down and when it reaches its boiling point and goes down beyond its boiling point, then from gas it becomes to liquid state. Again that object, that liquid, if you further cool it and the object surpasses its melting point and goes down, the temperature drops, then from liquid it becomes to solid state. So change of state is observed when you heat and when you cool as well. Fourth one is chemical change. Now let me explain this one. The molecules that are there in an object, the molecules are very small, but to explain I have drawn them to be bigger. Now one molecule is attached with so many other molecules, right? So this attachment between one molecule and another molecule is known as bond. So these lines that I have drawn, each of them they are known as bonds, B-O-N-D-S. These bonds, they become weak when we heat. So if I supply heat to this object, is made up of molecules and molecules are holding each other with the help of bonds, then the heat disturbs the bonds or it reduces the bonds. The bonds break. Okay, heat makes the bonds to break, and when the bonds break, the molecules become free from each other and they become into something else. The object changes its structure and we call that change as chemical change. When heat is given, the bonds are broken and the object becomes from that particular object to something other than that object. That is called as chemical change. Fifth effect that heat brings is effects on living beings. We all know that heat is crucial to life itself. Without heat, this planet would die. Just imagine. Photosynthesis wouldn't happen if there was no sunlight, sun's heat. No heat from the sun, no photosynthesis. No photosynthesis, no food for the plants. And if plants don't live, we don't have any chance, because plants give us oxygen. And not only oxygen, plants give us food also. Directly or indirectly, we depend on plants for our food. So no plants, no food, no food, no us. No plants, no oxygen. No oxygen, no us. So heat is very much essential for living things. Not only for that, for growth also. We grow because of the things that happen inside our body. And that also, for that also we need the sun's heat. Okay? Our metabolism that is happening inside the cells of our body, for that we need heat. Okay? So heat brings life on our planet, and in our bodies also we experience growth because of heat. So these are the 5 effects that heat brings about. The next thing that we need to know about is good conductors of heat and bad conductors of heat. Conductors are those objects which absorb heat. Not only absorb heat, but readily absorb heat. They absorb heat very fast. So they are called conductors or simply good conductors. All metals are good conductors of heat. Okay, all metals absorb heat. Some absorb faster than the other, but in general, all metals, they have the capacity of absorbing heat. Insulators or bad conductors are those objects which do not absorb heat very fast. They take a lot of time to absorb heat. For example, paper. Paper does not absorb heat, but it gets burnt before it absorbs heat. Then you have wood. You place wood on fire, wood will not absorb heat, but it will get burnt up. Okay, there is something called as ignition temperature that we will study afterwards. For metals, the ignition temperature is very high. So when we place metal inside fire, its ignition temperature is very high. That means it will take a lot of heat to burn a metal, or in fact to melt a metal. So for that we need thousands of degrees of temperature, degrees Celsius of temperature. So for paper it's not so, for wood it's not so. For wood and paper the ignition temperature is very less. For a little bit of heat only from the fire, its burning is reached and it starts to burn. So wood, paper and what else? Rock, cement, these objects, if you try to burn them, if you try to put them in fire, they might get burnt, charred, like wood and paper. But other substances like rock, they will not burn, but neither they will absorb heat also, or it will take them a lot of time to absorb heat. So those objects which take a lot of time to absorb heat, or which get burnt in that process of absorbing heat, they are bad conductors of heat. Whereas good conductors of heat are those objects which keep on absorbing heat very fast. They get heated very fast, alright, like metals. Okay, to explain the difference between good conductors and bad conductors, here is one experiment. It's given in your book, page number 49. Okay, examples to illustrate good and bad conductors of heat. For that, we need 2 cylinders. One made up of brass, brass is a metal. Another is made up of wood. 2 cylinders of equal size and shape. What we do is we join them like this and we paste a paper that is wrapped equally on brass as well as on wood, and we apply gum so that we can make them fasten together, hold them together. So brass and wood both are held together with a white gummed paper. Gum means atha. Okay, with that gum we have pasted brass and wood equally in the joint, so that half portion of the paper is holding brass and half portion is holding wood. Now what to do? Take this joint above fire. Now don't hold it for long, otherwise the whole paper will burn. Only for a brief moment, small moment of time, you take this joint so that the heat is supplied in the joint, both on brass as well as wood. The heat should be falling. What we will observe is the paper which is towards the brass, nothing will happen to it, whereas the paper which is covering wood will get burnt. Now why this happens is, the reason is, brass is a good absorber of heat, so most of the heat the brass will absorb. So paper will not get the amount of heat which is needed for it to burn. So paper above brass will be left as it is, or maybe a little bit black it will become because of carbon coming from the candle's flame. But the paper which is holding wood is a bad conductor of heat, right? It's a bad absorber of heat. So what will happen? The heat, instead of being absorbed by the wood, will be used up for burning the paper which is holding the wood. So the portion of paper which is holding brass, nothing will happen to it, but the portion of the paper which is holding wood will get burned. Reason? Brass is a good conductor of heat, so all the heat of the candle will be absorbed by the brass and the heat will not damage the paper. Whereas wood is a bad absorber of heat, so wood would absorb any heat from the candle, so the paper which is holding the wood will get burnt. So this is the example to illustrate good and bad conductors of heat. Okay, this is another experiment to show conductivity of substances. Now in this case the metal rods are used. Now this experiment was conducted by the person Ingenhousz. So the experiment is given after his name, Ingenhousz experiment. Alright, in this experiment there is a hot water bath. Okay, this is a bath. Bath is a place where we keep water, used for bathing purpose maybe. So it's a hot water bath with 1, 2, 3, 4, 5 holes in it, and of course the bath is filled with hot water. Now this should be very super hot water, so that it is good enough to heat the metal rods which are connected. Now these metal rods are connected, the inner part of the rods is in contact with the hot water. So hot water is actually heating these different metal rods. Now what we do, before pouring the hot water in this bath, these 1, 2, 3, 4, 5 metal rods are coated with wax. Wax, mombatti, that wax you take and you coat it fully from this length to this length of all the 5 rods. Okay, when you coat it with wax, then you put the hot water inside this water bath. So water bath, the hot water will touch these individual 5 rods and will start heating them. So when the rods get heated, what will happen to the wax? The wax will start to melt and fall. From all of these rods, the wax will start to melt. So when the wax starts to melt, you observe which metal rod is the one from where the wax starts melting first, or the wax totally melts. There will be not same rate of melting. Okay, all different 5 metals, they absorb heat differently, isn't it? Everybody's capacity of absorbing heat is not same. So all the 5 metals are 5 different metals. So I haven't written down the names of the metals as such, just to see which metal rod is the one from where the wax starts melting faster, at a faster rate. So that particular rod's conductivity is more. Okay. So from this experiment, it is proven that not all metals absorb heat in the same rate. Some absorb heat faster than the other. Depending on how fast the wax melts, we can judge the conductivity of that particular metal. So Ingenhousz experiment is used to demonstrate what? That different rates are there of absorbing heat for different metals. Now on page 49 and on page 50, they have given us different uses of good conductors and bad conductors. That is, different applications of good conductors and bad conductors. how it is good for us, and how where in our life we apply them. So I want you to go through these 2 pages. The topic is uses of good conductors and bad conductors. For both good conductors and bad conductors, the uses have been given. So I am not going to discuss here in the class. It is better that you go through it by yourself. It is not something that you wouldn't understand. So just go through it, make a reading of it, and you will understand.